I just created my own language inside Minecraft, and this lectern you see right here, it can go from computing areas of graphs to playing tic-tac-toe with the player. But why? You see, a few weeks ago on Discord we were discussing just how bad bedrock commands are. And then suddenly I had a genius idea. What if I make a pack that completely rehauls Minecraft commands? Before I could even get started, the person I was talking to sent me this. So I decided to do something unique. So surely no one has ever made a custom language in Minecraft, right? Before we start building it, I set a few targets for this language. First, it has to be readable. Even someone who has never coded before should be able to understand it. Second, it needs the basics like loops, functions, variables, etc. And lastly, it's dynamic. And if you don't know what that means, I will explain it in a while. Now if you have played Minecraft Bedrock, you will know this, but let me clear things up. There are two types of packs, a behavior pack and a resource pack. In one line, behavior pack control how the world behaves, and a resource pack control how things look. Since we're dealing with world behavior, we need a behavior pack. Every pack needs a name and a description, and all of that is stored in something called a manifest file. It looks something like this, but we mostly care about two things, the name and the description. I would name it Steve language, and for the description, I would add this. Every pack has a nice looking icon, but I don't have one. So for now, I'm just using this picture of my skin. Now my plan is simple. We will write the code inside a book, then when we hold the book in our hand and type something like !run, it will run the code. And of course we need an output. I think the chat is the perfect place for that. But there is one important issue. Since our language is written inside a book, we need to make sure only the right people can use it. In Minecraft Bedrock, there are 3 permission levels. Visitors can only walk around, members can interact with the world but cannot use commands, and operators can do everything. So naturally, we are only letting operators use this language. Alright, let's code it. There is something called the after events, which means we are checking right after an event has occurred. In this case, the event is someone typing !run. Now this looks weird, but the idea is very simple. First of all, you will see we wrote event, which is the chat message event we are looking for. Now a chat message contains two things, the message and the sender. For example, we can send a player a message every time we type in chat. Now when I type something in game, it sends me a message. Now we have to check if the player is an operator. Now instead of checking if the sender is an operator, we will check if the sender is not an operator. It is just easy to do it like this. Now we also have to check if the player even has a book and quill in his hand. For that, we can just do something similar. If I type run without holding a book, it sends me a warning. If I do hold a book though and run the command, it doesn't send me any warning. But it also doesn't do anything. Now we have to actually make the language executor. But what exactly does the language need? First, the language needs a way to talk back to us. I'm going to call it save because it's very clear what it does. So if I write something like, say system online, when we run it, it sends a message back saying system online. Now what if we want the code to react to something? If they are here, we do one thing. If they are somewhere else, we do something different. That's where if comes in. We can write something like this, and if the condition is true, it executes this part, and if it isn't true, it executes the other part. And finally, we need a way to store information. And that's everything we need for now. What we will do is pause. Now while making this, I actually looked into how real languages work. And turns out they do something called tokenization, where they break down every word and figure out whether it's a variable, a function, etc. But when you actually try to build that, it gets really complex. So instead of building a full compiler, I did something much simpler. I just check what each line starts with, like say, if or repeat, and handle them one by one. We will split each line of the book and read it one by one. To make the say function, I will check if the line starts with say. I will slice the entire line at these indexes, and what I'm left with is the message. And on the first attempt, it did work. I was very happy when it happened because it took some time to get it working. After that, I added some error handling, and we are done with that for now. Now on to the fun part, variables. At the start of the video, I said I will explain what a dynamic language is. So consider this. If we have a variable x is equal to 10, the value of x is 10. And the type is an integer. In a dynamic language, I can not only reassign values to a variable, but I can also change its type, unlike non-dynamic or more precisely static languages, where the type of the variable cannot be changed. Alright, I am thinking I will use this format for variables, like Steve x is equal to 10 and now x holds the value 10. Again, since I'm not using tokenization, there isn't really an easy way to check if the user typed the correct format. But what I designed works for the most part. First of all, I split the line at the equal sign. If there are more than two parts, that means the user typed more than one equal sign, so it's wrong and we reject it right away. And for the first part, we split it at the white spaces. If there are more than two parts, that means the user again typed the wrong syntax and we just reject it right away. For the second part, we just check if it is a text, integer or float. Now what if it isn't a text and also isn't a number? Well, I will get to that in a while. Alright, I think this works perfectly. I can do name is equal to efficient123 and when I write say name, it prints the name. I can also print numbers and initialize multiple variables. This also took some time to get it working. Now back to the question I asked. What if it isn't a text and also isn't a number? Well, that just means they might be referencing another variable. Now I can do things like x equals 10, y equals x, z equals y, and when I print z, it prints 10. And with that, we are done with variables. Now if you remember, I talked about if statements. This is what allows the language to make decisions. This is also where I started slightly regretting making this video, because the implementation was annoying, but in the end it worked. The format looks something like this. If condition, then we write some code, then we write an else, and then we finally close it with an end. Now my executor reads the code line by line. When it finds an if, it stops the execution and collects every line until it finds an end. Then it checks the condition. If the condition is true, it runs the first block. If it's false, it skips to the else block instead. And then it restarts the line by line execution. In simple terms, it behaves like a real if statement. And after a while of trying, it works. If I define x as 2 and y as 3, I can write things like if y is greater than x, say yes. Otherwise say no. When I run it, it says yes. If I change x to 4 so that x is greater than y, it says no. Now we are almost done with the language. We just have to add functions and loops. So far the language can store and compare things, but it cannot perform operations on them. So I focused on arithmetic before anything else. The logic wasn't that hard to implement, but there were some obvious bugs. It returned 25 for 5 plus 2 and 4 for 2 plus 5. After fixing it, we can finally perform operations. I can now compute averages, the distance between 2 points, areas of almost anything, etc. Now though we have so many things to do with our language, it adds one major issue. Let's say we have to compute the average of two numbers. Well, that's easy. We just add them and divide by 2. What if we were given 20 pairs of numbers? Now yes, obviously we can just repeat this 20 times, but notice how we are doing the same thing every time? What if we could just write that once and reuse it every time we need it? That is exactly what a function does. The syntax I chose looks something like this. We say function, then the name of the function, and then its arguments. To use the arguments, I put them inside forward slashes. Then we close the function by doing function end. Now so far this was the hardest one to make, but after a while I figured this out. Just like if else, when we reach the first line of a function, we stop executing and start collecting each line until we hit a function end. Then we split the function name and the arguments and save it in memory. Next time someone calls the function, we check if such a function exists. Now this is the important part. We replace each argument in the original function, and what we are left with is something we normally write outside any function in our language. So we can just treat it like any piece of code and continue execution. Actually testing the theory, here's what we get. I can do function add a and b, and then I can write sum is equal to a plus b. Then we print it and end the function. Now I can invoke the function by writing add 3 and 4. When I run it, it prints 7. You can write multiple arguments and do mostly everything the language allows. Here is an example of an average function. And now I can do average of any two numbers in one line. With that, we are 95% there. We just have to add loops. Now implementing loops was almost the same as functions, except you just call it multiple times. So there wasn't really anything interesting there, but it works. I can write repeat 10 and then the code and then repeat end. And when I run it, it sends the message 10 times. And finally, this isn't really needed, but it does make the language easier to work with, which is accepting user inputs from chat. I will call it read next, which tells the language to read the next thing user types in chat. Now I had to find a way to halt the executor at this line until the user types something. If you run this, the language waits for a chat message. And when you do, it is stored in a variable which you can use later. For example, now we can do the average by asking the user for input through the chat. And with that, the language is done. The language can now store variables, has inputs and outputs. It has if statements, loops, functions, and arithmetic. Now here are some cool things we can make with this language.